Cauchy's first theorem of limit. If an tends to L, then xn is equal to a1 plus a2 plus a3 plus so on an upon n tends to L. Now proof, let Tn is equal to an minus L, that is an is equal to Tn plus L. Now xn is equal to a1 plus a2 plus a3 plus so on an upon n is equal to T1 plus L plus T2 plus L plus T3 plus L plus so on plus Tn plus L upon n equals to NL plus T1 T2 so on Tn plus Tn upon n is equal to, so xn is equal to L plus T1 plus T2 plus so on Tn upon n. Now an tends to L and Tn tends to 0, so the given epsilon greater than 0 however small, there exists a positive integer m such that modulus of Tn is less than epsilon per 2 for all values of n is greater than or equal to m. Again, as Tn tends to 0, so sequence Tn is a convergent, which implies Tn is a bounded, so there exists a real number k such that modulus of Tn is less than k for all values of n. Equation 3. Now T modulus of T1 plus T2 plus so on Tn upon n is equal to modulus of T1 plus T2 plus T3 plus Tm plus Tm plus 1 so on plus Tn upon n is equals to modulus of T1 plus T2 plus Tm upon n plus modulus of plus T1 T plus m plus 1 plus so on Tn upon n. So this will equal to, यह दो टर्म का मॉडुलस हो जाएगा t से tm प्लस 1 अपॉन n का मॉडुलस और tm प्लस 1 से tn अपॉन n, tm 1 से tn तक का मॉडुल अपॉन n का मॉडुलस. So this is equal to now modulus further modulus individual term का modulus के equal हो जाएगा. So which is less than equal to of t1 modulus plus t2 modulus plus so on tm modulus upon n plus tm plus 1 modulus plus so on tn modulus upon n, which is less than of mk upon n plus n minus 1 upon n is less than epsilon upon 2 because of 2 and 3. So which is less than equal to of mk upon n plus epsilon upon 2. So modulus of t1 plus t2 plus so on tn upon n is less than equal to mk plus epsilon upon 2. Equation 4. Now mk upon n tends to 0 as n tends to infinity. There exists a positive integer p such that mk upon n is less than epsilon upon 2 for n is greater than equal to of p. Equation 5. So limit q is, let q is equal to maximum of m of p. So modulus of t1 plus t2 plus tn upon n minus 0 is less than equal to of epsilon upon 2 plus epsilon upon 2 for n is greater than equal to of q, because 4 and 5, 4 is mk plus epsilon upon 2 and 5 is mk is less than epsilon upon 2. So in place of mk writing epsilon upon 2, so this is equal to epsilon upon 2. So t1 plus t2 plus so on tn upon n minus 0 is less than equal to of epsilon for n is greater than q. So from 1 let x limit x and to limit n tend to infinity. And so limit n tend to infinity a1 plus a2 plus so on an upon n is equal to l.